Hello everyone, I'm Takuma Yagi from the University of Tokyo. Today I'd like to talk about GoFinder, a registration-free wearable system for assisting users in finding lost objects via handheld object discovery. In this study, we study a very common problem of finding lost objects. Regardless of ages, we spend so much time to find lost objects. One survey reports in the US that we spend 2.5 days per year, 5 minutes per item for finding lost object, which is a waste of time, and thus computational support to help such finding object is required. Since this is an important problem, many support systems, for example, using radio frequency identification, BLE, or wearable cameras have been already studied. For example, in this case, they attach a RFID tag to the object, or in this case, they use a bulkhead mounted camera to capture a video from the user's point of view. And the last period of timing of object is kind of retrieved by the names. However, prior systems have two critical assumptions, either attaching external sensors or markers to the objects, or registering the appearance of object in advance. However, this assumption was a problem since it assumed that we already know which object would be likely to be lost beforehand, before actually losing the objects. This is a pretty strong assumption, and it cannot deal with unexpectedly lost objects. And we want to challenge to this problem. Our approach is similar to prior work using neck-mounted roll camera, and its basic idea is to track every object locations from the videos and shows the last appeared timing of them for each object to help users remind the locations. However, we aim to develop a general object finding system which eliminates the needs of registration and not limited to registered objects. However, this is not so simple. Although wearable cameras are used for many types of products, the common problem here is that massive number of images or objects will be taken during recording. For example, the SenseCam is the most famous camera developed by Microsoft, but it produces hundreds of thousands of images, to look back, it requires quite a lot of time to kind of look back the events. Besides, object finding should be assisted instantaneously without taking time. So this is a kind of a problem. So here, technical challenge will be how to search the last moment rapidly for each object, and also how to represent objects without asking users to name them will be another problem since we want to eliminate the registration phase. Here we propose GoFinder, general object finder, by making two critical assumptions to achieve clear the issues. First assumption is that we assume that objects we lose are handled by hands. So since hands are the primary way to interact with our environment, it's natural to assume that object we typically lose is handled by hands. This will significantly reduce number of candidates to be searched for. And also, we use a list of object thumbnail images themselves to select which object to look for. And here we show the interface of our system, which consists of handheld timeline pop-up screen. And this timeline shows the object thumbnail images as a list from latest to oldest. And by clicking the thumbnail image, we could retrieve the last timing of this object, which eliminates to name each object. And here we show the examples are retrievable by the participants. So this is actually a smartphone app, and by using the app, we can instantaneously find where the object is, and they could retrieve the object correctly and quickly. Now let's move on to how to construct these object timeline. So basically, we use a computer vision approach for this. And given a video frame, we first detect the hand and also corresponding handheld objects. And it basically iteratively apply this procedure to get a list of handheld objects. And the next step is to cluster those by instances. As the input frame grows, we want to grow the object cluster if the appearance of the objects are similar. So in this case, we apply tracking between edges and frames. But in some cases, there will be an occlusion or out of frame detections, which could result in no detection. In such cases, if the same appearance object appeared, it's not straightforward to connect those. But in this case, we apply a clustering phase to compare the we calculate the convolutional neural network feature for each patches and calculate the cosine similarity between latest detection and existing clusters detections. And in this case, the mean similarity is above the threshold. We would merge them to form a single cluster. And by doing this clustering process, we could obtain the last thumbnail images and the frame of last appearance and we can show them that to the user interfaces to the user to remind the locations. We conducted a user study of 12 participants to verify whether the users can remind the location of objects by using system. So it consists of 3 phases. It's basically hide thinking performed by themselves. So in the arrangement phase, they hide 16 objects within 20 specified locations. However, which object to hide for is left for the users. So they hide 16 objects to arbitrary specified but arbitrary locations. After that, they get a forgetting interval about 15 minutes by solving a calculation problem to take enough time to forget some of the locations. And the retrieval phase, they're asked to bring back 6 out of 16 objects correctly. And we were asked to bring back only the specified objects since we want to measure how accurate they could bring back the object. And we compare with the experimental conditions with no condition without any assistance and our object-based aid we're using GoFinder. And we also prepared a frame-based aid which resembles SenseCam's image-based wearable system. So it's kind of showing the images taken every 5 seconds and which designed to enhance the user to remind the locations by looking at the past images, not the objects themselves. And object sets were kind of consistent with these kind of various objects, and the object set and the ordering was kind of shuffled to eliminate ordering effect. We also skipped the system evaluation due to limited time and report the user evaluations here. And we compared how accurate the retrieval was, and the result shows that by using our system, the accuracy was quite improved than using other conditions. And we conducted statistical analysis, and we observed a significant difference between frame-based data and object-based conditions, but not in no data object-based conditions. However, we observed large effect size between those two, and it seems like there indicates some differences or improvement of the retrieval by using our system. And also, we asked the participants how difficult was it to accomplish the task. And the situation was similar here, as we observed significant difference between frame-based data and object-based data, but not between no data and object-based data condition. However, we also observed medium effect size, which somewhat indicates some improvement in indicating less mental load required for using the object-based data condition. And we also measure the task completion time here, but we did not find significant difference. And it seems like using our system was not beneficial nor harmful for object search task. We have 3 findings here. And first finding is that participants successfully memorized the location by using the system, which is kind of fairly promising result. And participant feedback suggests that they gain confidence by immediately accessing the last moment. And we found that they actually trusted the system more than their own memory. And the second finding is that participants adapted quickly using handheld object timeline. Although we only did a very brief introduction, a few confusion reported due to low quality thumbnails and over segmentation reported since our algorithm is fully automated and not perfect. And the third finding is that frame-based data actually confuse participants and more harmful than no-wait conditions since it does not hold direct cues on object location. And it seems like SenseCam-like interface did not help enough in this object finding task. I want to mention about privacy issues. And this is a serious problem, but we believe that it's less harmful than expected because GoFinder is fully automated. And also we do not need to maintain all the frames. So storing the last frame per object is enough. And also, since this is an object finding task, facial information could be discarded or removed without sacrificing its performance, which could somewhat protect the other person's privacy. Here's a conclusion. We propose a registration-free wearable camera-based system for assisting users in finding lost objects. And the proposed handheld object timeline enables the user to remind object locations accurately with less mental load, also quickly. Thank you for listening.